Hello everyone, let's get started with this problem. The question is a small block of mass m. M actually is not given, but actually it is 1 kg. It's a misprint. Is kept on a rough inclined surface of inclination theta is equal to 30 degree. And the surface is fixed in a lift. The lift goes up with a uniform velocity v, 4 meter per second, and the block does not slide. Block is not sliding. Means along this direction there is no v. V is equal to 0 with respect to the frame attached to the lift. So the work done by friction on the block in 1 second is being asked in the question. The lift is moving with uniform velocity v in the upward direction. So acceleration in the vertical direction will be 0. There's no acceleration in this direction. Your block does not slide on the wedge as per question. So this acceleration of this also in the y direction will be 0. Here in the v direction will be 0. V means vertical, you can say. So now let's examine which all forces are acting on the block. The forces acting are the gravitational force mg. This mg has been subdivided in two components. Along the inclined it is mg sine theta. Perpendicular to it is mg cos theta. This force is the normal reaction from the wedge to the block. Wedge is rough, so friction force is acting in this direction because in the question it is given that the block is not sliding on the wedge, but it will have a tendency to slide in this direction due to the component of force mg sine theta. So as we know from the friction concept that the friction force acts opposite to the tendency of motion of the surface of contact. So surface of contact for the block is this. So the friction force will act in this direction. So we have transferred all the force by showing it the block as a particle in this diagram. Our concern is for the work done by the friction force. And the friction force is acting along the inclined surface of the wedge. So we will consider all the forces along the incline. There is no acceleration along the incline. Acceleration in the incline 0. So we can write Fr minus mg sine theta, because mg sine theta is acting opposite to friction force, as mass into acceleration along the incline, that is 0. So your Fr will be equal to mg sine theta. If you put all the value 1 into 10 into sine theta is sine 30 degrees given, 1 by 2. So this will be equal to 5 Newton. To know the work done by friction force, we must have the displacement along the friction force. Your block is moving with uniform velocity in vertically up direction. So in t seconds, it will displaces by Vt in the vertical direction. The component of this along the friction force we are interested to know about from geometry. This angle will be 60 degree because theta was 30 degree. So this is pi by 2 minus or 90 degree minus 30. So this will be 60 degree. So the component of Vt along this will be V into Vt cos 60 degree. So work done by the friction force in t seconds, we can write like this: Fr into displacement along the friction force in t seconds. Friction force we have already calculated, 5 Newton. St is your this. Just put the value Vt cos 60 degree. V is 4 meter per second. Cos 60 degree will be half. So 5 into 4 into t 1 by 2. But question is asking about the work done by the friction force in 1 second. So work done by the friction force in t is equal to 1 second will be, just put the value of t as 1 second in there. So this will be 10 joule. So your answer will be this. Hope no issue in understanding. If any issue in understanding, please do write in the comment box.